everyone, I C.H. Shanti, working as assistant professor under the stream of Computer Science and Engineering in BV's Institute of Technology and Science Engineering College, Amalapuram. Here I am presenting a video on CSMA, a random access protocol, where we are using this random access protocol. It is a contention methods which are used to avoid or to detect the collisions on multiple access communication or median access communication. We're having mainly two types of random access protocols. Here I am presenting one of the model, that is CSMA. Coming to definition of random access. Random access means no station is superior than other station. None station is assigned as a controller over another stations. At instance, if any station want to sense the frame or message, it will verify the carrier and taking its own decision to send the frame or data. This is the process of random access. In this random access, we are discussing a protocol called as an CSMA. Coming to the full form of CSMA, CSMA means carrier sends multiple access. What is the main goal of CSMA? To minimize the chance of collision and therefore to increase the performance of multiple access communication, we developed a concept called CSMA. That means if we want to send a frame or message or the information, the node should listen and it should sense the carrier in a medium, and if the carrier is ideal, then we send the message. The chance of collision can be reduced if a station sends the medium before trying to use it. It will works under the concept or the principle, which means sense before transmit or listen before talk. The explanation means before talking we should listen, then we have to speak. Likely, before transmitting, we sense the carrier signal presented in the transmission medium, whether it is free or not. If it is ideal, then we send data. If it is in busy state, then we will wait for some amount of time. By this, we reduce the possibility of collision. Here, CSMA will reduce the collision, but it cannot be eliminate the collision. Let us go for the diagrammatic representation of the collision in CSMA. This is the diagram to represent the time or space of a collision. Here I am showing 4 different types of stations, and all the stations are ready to communicate in the shared transmission medium. We have to observe that all the stations will transmitting on the same shared common transmission medium. Initially, I am taking the 2 stations as an example in this diagram. Here, let us assume that the B station and C station communicating. Now, let us, each and every station's time will be defining here, and initially first the B station transmits the data at the time interval T1, and C station transmits the data at the time interval T2. Let us go the explanation how the collision will takes place between the transmissions of frames or sends from the stations B and C. At T1 time interval, B started transmission of its message or information, and parallelly C started transmission at a time interval T2, and C does not recognize the carrier signal which has sent by the B, and C does not know the B started because B data does not reaches C. Hence, C does not know whether the station B transmitting the data or not. So, C also started on different time interval, that is T2. But as we are observing that these two stations are on same shared medium, somewhere else on the transmission medium there is a chance of occurring collision. To reduce this collision, the CSMA scheme differs different mechanisms or different methods to verify the station and to verify the carrier whether it is in idle state or busy state. That can be shown by using the word that is called persistence method. Now, let us go. What is a persistence? Persistence means before sending of data from any station in the network or any node in the network, what should a station do if the channel is busy? What should a station do if the channel is idle for transmitting whatever the information it is having? To verify the channel busy or idle, we are having three different types of methods. They are one persistent method, non-persistent method, p-persistent method. Here I am explaining these three methods by representing the flow diagrams. Let us go for these diagrams. The first one is one persistent method. In this method, if the station is trying to sense the information and each and every time it is continuously checking whether the medium is idle or not. That means, as you are seeing the diagram, before sending of data, we have to verify whether the channel is free or not. If the channel is busy, then we have to verify other time. If the channel is busy for the second time, we have to verify for the third time. We have to verify up whenever the channel will become in an idle state. Up to that time, we have to verify, we have to check continuously. That is one persistent method. And coming to the second method, that is non-persistent method. Non-persistent method means in this, the station first sends, and if it find the medium is not idle, then it is wait for certain period of time and sends back again. If it is still busy, it wait for another random amount of time. After completion of random amount of time, if it is idle, it sends that whatever the information it is having. Otherwise, it is simply skipped from the transmission medium. As you are observing, before transmitting of that, it will wait for random amount of time and then it will go for verification of channel transmission medium, and again if the channel is idle, it transmits the information. Station can transmit the information, or if it is busy, it wait for random amount of time. Continuously it will wait for random amount of time. That is the non-persistent strategy. And go for the next method, that is called p-persistent method. P-persistent method is nothing but it continuously tested like one persistent method initially. That means it verifies whether station is free or not, whether station is free or not, whether the station is free or not, continuously up to certain time intervals. Then if it is still the transmission medium is busy, it chooses time slots and it waits for certain time slot intervals. Then after checking if the medium is not occupied with other station, that means if the medium is idle, then it transmits the information. That means here in the non-persistent method, it will wait for certain time period. In P-persistent, it will wait for time slots. It chooses a random amount of time intervals based upon the probability, and it will define the time slots up to greater than P, and it will checks the channel up to that P value only. This is P persistent method. Based upon these three methods, the CSMA can reduce the collision but not completely eliminate the collision. Now we are going for the CSMA methods. The CSMA having two methods to reduce the collision. Among that, the first method is carrier sense multiple axis with collision detection. CSMACD is a network protocol for a carrier transmission that operates in medium axis control layer. Like CSMA, it sends or listens whether the shared channel is busy or not before transmission of data. The CSMA scheme reduces the collision in CSMA-CD by the following two regions. Firstly, by reducing the vulnerable period for 1 or 2 frames transmission. And secondly, in this protocol here, no station begins to transmit the information when it senses the channel is busy. If and only if the channel is ideal, then only the station transmits data. Now, if the station knows that a collision has occurred, then the amount of transmission time and wasted bandwidth can be reduced by aborting, that means by stopping the transmission when the collision is detected. That is, if two stations sense the channel is idle or begin the transmission continuously, collision takes place. They will both detect the collision almost immediately. Instead of waiting until finish the transmission period, even though the collision occurs before that time period, they should immediately stop or abort the transmission as soon as the collision is detected by the stations. This approach is called as an CSMA-CD. We are having the CSMA-CD flowchart for the clear explanation how the collision will be detected. Before that, we have to follow the CSMA-CD algorithm. In this algorithm, when a frame is ready for transmitting of data, it verifies whether the channel is idle or not. If the collision is detected, the station starts the collision resolution algorithm by transmitting the jam signal. Here, how the collision resolution technique will be applied. The station continues transmission of the current frame for a specified time along with the jam signal to ensure that all other stations have to be detected. Here the collision will be takes place. The station increments the retransmission counter. If the maximum number of retransmission attempts is reached, then immediately the station will abort it. Coming to the flow diagram of CSMA-CD. In this flow diagram, I am clearly explaining how the collision situation will be identified. Now, initially the station has a frame to send. At first time, if you are transmitting the first time, we are taking the number of attempts as a k, as I am representing here. And for the first time, I am taking k equal to 0. The first attempt is 0. Applying one of the persistent methods, before we are seeing one persistent, non-persistent or p-persistent, to check the transmission medium, carrier signal is busy or in idle state. If the transmission medium is in idle state, the transmission will be done and the data will be received or the frame will be received to the station. In case if the transmission is done without collision, it transmit, and after transmitting it receives and it goes for the second bit. That means the flow will be done between these two only. That means transmit and receive the bit, and it again sends the information for the second bit, and transmit, and after receiving it transmit to the other destination station, and again it will go for the third bit. Like this continuously among these two stations, these two steps, the process will be continue. If it finds any collision, then it go for the collision block, and it will send the jam signal to the remaining stations to be alert that here somewhat of collision will be takes place, and the remaining station does not have a chance to send the frame whatever they are having. After sending the jam signal, it increment the second attempt by using the formula, that is k equal to k plus 1. That means if you are taking k equal to 0, and now we are going for the second attempt, that will be taken as 1. And if we are taking for the third attempt, that is 2 plus 1. If you are taking the fourth attempt, that is 3 plus 1, like that. And here we are choosing a probability of times. Here maximum in the CSMACD, the k max is normally 15 times. If the k max is 15 times over, then simply the station frame will be aborted from this place here. Now after incrementing the k number of attempts, it will choose the random amount of time by taking as an r slots, random number of slots. That random number of time interval will be defined based upon this formula 2 power of k minus 1 times for defining the time interval. And after waiting the random amount of time, it will verifies again whether the transmission medium is free or not. If by applying among these three methods, if it is free, it transmit. If it is busy, again it increment the carrier. It increment the number of attempts and sends the jam signal to the remaining stations and wait for r time slots, and after completion of time period again it senses. This is about CSMA CD. In CSMA CD, a station is ready with the frames. Compulsory, it verifies whether station is idle or not. If the channel is busy, there is no possibility of sending of data, and it compulsory persist back by applying three possible strategies, that is P persistent, 1 persistent and non-persistent. This is about CSMA CD. CSMA CD is also called as an back-off algorithm. That means resensing number of times for transmitting of a frame to the transmission medium. Now, to reduce this problem, that means if the k max is completed, simply it will be aborted. That means here the collision is, the sending of frame is not completed. So that we are evolving the next method, that is CSMACA. Carrier sends multiple axes with collision avoidance. CSMACA is used for wireless network. In wireless network, most of the energy is lost due to transmission. So, collision detection is somewhat different. To avoid collisions in CSMACA, we are having mainly three different types of strategies. That is IFS, contention window, and next one R-cross, that will be shown in the following flowchart. Now, in contrast to CSMA-CD, the CSMA-CA will be defined after the collision will be occurrence. CSMA-CA prevents the collisions prior to their occurrence. It is also operates in the medium access control layer. Now, let us go for the algorithm of CSMA-CA. When the frame is ready, Then the station checks whether the channel is idle or not. If the channel is busy, the station waits until the channel becomes idle, that means free. If the channel is idle, then the station waits for interframe gap, that is interframe gap or interframe space, IFS. Here, what is IFG or IFS? Interframe gap means it is a time interval or a time gap to wait for random amount of time. Initially, medium is checking. When the medium find ideal, then it will wait for some amount of time that will be called as an IFS. After sending the frame, it sets the timer. Thus, if the station then waits for the acknowledgement from the receiver. If it receives the acknowledgement before the expiry of time, it makes that the transaction or the transmission will done successfully. Otherwise, it will wait for the back of time period and restarts the process again. This is the flow chart for the explanation of CSMA CA. Here, for the number of attempts, we are defining k equal to 0 for the first attempt, and if the channel is free, then we are transmitting the data or the information. Whenever the station finds that the channel is free, then it will wait for interframe space or it will wait for interframe gap, that is some period of time. And after waiting, again if the channel is free, then it sends the data, or if for suppose whenever the station will not be free, then it will go for the second time verification, sensing of the second time. After IFG or IFS, if the channel is still in a free state, then it transmits the information, or if the channel is in busy state, again it will go for sensing of the transmission medium. And again it will wait for IFG. That means here, after finding the station, the transmission medium is in idle state, it will wait for random amount of time. And after the time completion also, IFG also, it will again senses. If it is free, then it transfers the information by using contention window. What do you mean by contention window is nothing but, for transmission of time, we have to choose a random number of R time slots. And within this time slots, we have to transmit the information. Here, we have to choosing the binary exponential size. That means there are n number of time slots. And there it will wait for these time slots. After that, it sends the frame and then it will set the timer to sense the frame. Within the time period, the contention window is nothing but defining of R slots. R slots is nothing but time period slots, and these time period slots will be depends upon the size that will be based on 2 power of k minus 1. After waiting, we have to send the frame and we have to set the timer. By completing this time, we have to successful transmission will be done, and from the receiver we have to get the acknowledgement. If we are not getting the acknowledgement, we are assuming that there is some type of collision will be takes place, and we are incrementing the second time attempt, and again we have to go for sensing. This is about CSMA CA. What is the main difference between CSMACD and CSMACA? In the CSMACD, if we are observing that, if we are finding that, or if we are detect the collision, then immediately that station ensures by sending the jam signal to the other stations to be wait for some amount of time, and it will go for the second attempt, and again it will check. But In the CSMA CA, we are not at all sending any jam signal, but before sending of a frame, while first time sensing the medium, if it is free, we are sending the frame, but before sending of frame, again we are going for wait for some amount of time, and after the time completed, again we are sensing. That means second time we are sensing the medium whether it is free or not. After second time sensing also, if the channel is idle, then again we are going for R time intervals. That means for sending of a frame or a message from one station, we have to wait. We are giving the time slots up to 2 times. For first time based upon IFG or IFS. For the second time based upon contention window. IFG is nothing but fixed time interval. After fixed time interval, again we sense the medium is free or not, and we are going for transmission. Again, if the channel is free for this, after completion of IFG, before sending, we are giving the contention window, that is R slots, and after completion of that R slots, we are transmitting the data. That is CSMA CA. Hope you understand about the CSMA CD and CSMA CA. What's the purpose of these two and where we are using these two. Thank you.